Okay, today we're doing lecture 8, intervals of increasing and decreasing. So when I think of increasing and decreasing, I think of, moving up and moving down. So the first thing I wanted to say is increasing is when a function goes up and decreasing is when a function goes down. And there's a definition for increasing, decreasing, and I just wanted to go over that before we start getting into examples. The first thing we're going to do is we're going to let f of x be defined on an interval. We're going to let x sub 1 and x sub 2 denote points on that interval. So all x1 and x2 are is their x values, while f of x1 and f of x2 are going to be y values, right? So you're going to have these x values, which are points on that interval, and we say that f is increasing if f of x1 is less than f of x2, whenever x1 is less than x2. So notice how you have that less than symbol. And what that's going to do is it's going to allow the function to go up. So essentially what happens is, and I'll show you on this picture, when you have an increasing function, as you go to the right, the function is going to be going up. Whereas if you have a decreasing function, that function is going down as you go from left to right. So that's the difference between increasing and decreasing. So you'll see that when we do intervals of increasing and decreasing. Okay, so that is the definition of an increasing function. That just means the function is going up as you go from left to right. And we also say that the function is decreasing on that interval if f of x1, whatever y value that is greater than f of x2, whichever y value that is, whenever x1 is less than x2. So what that means is your first y value is going to be higher than your second y value, which means as you go on the x-axis and you follow that, the function is dropping, it's decreasing. So whenever the function is going up, we call it increasing, and whenever the function is going down, we call it decreasing, okay? And then there's one last thing that I did want to talk about before we leave this slide. It is f is constant. So what does constant mean? That just means the function is flat. It's not going up, it's not going down, it's staying constant. So we say that the function is constant on an interval if f of x1 is equal to f of x2 for all x1 and x2. And what that basically means is you're going to have the first y value, you're going to have the second y value, and they're going to be equal. So if you have equal y values, what that means is the function is just kind of flat like this. So if the function is ever flat, we call that constant. So basically, when you're looking at a function, you're going from left to right, and increasing is when a function goes up, and decreasing is when a function goes down. So down here, I have a function, it's in red, and the function is going up. It's going up, 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 up. Imagine you're on a roller coaster, you're going up, 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 very slowly. You are increasing, right? You are increasing because the function is going up. And then once you get to the top of the hill, you start going down, you start decreasing. So then the roller coaster goes down the hill, it's going down, 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 it's picking up speed until you get to the very bottom of the hill. And then you start increasing again because the function starts going up again. It starts going up, 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 until you reach the top of the hill. And then whenever the roller coaster is flat, it's not decreasing, it's not increasing, it's basically called constant. So that's the difference between increasing, decreasing, and constant. Okay? So increasing and decreasing, very simple idea to understand. What's going to be more difficult for you is trying to apply it to a function. And we're going to get a lot of practice with that today. Okay, so before I leave this slide, I did want to tell you that concavity might be a thing that you're going to see. So if a function is concave up, that means that you have a U shape and it's basically going upwards on both sides. And the way I like to think about it is if you have a smiley face, that means you're concave up. But when the function is facing down, that's called concave down. You're going to have a frowny face. So that's the difference between concave up and concave down. You probably remember from the transformations lecture that whenever you have a positive number in front of the x squared, like let's say you have 3x squared, this is a function that's going to be facing up, right? But if you have a negative number, like let's say you have negative 2x squared, then that's going to be facing downwards, right? It's going to be opening up downwards. And we call that concave down. So if you have a happy face, that's concave up. And when you have a frowny face, that's concave down. Okay? And that only applies to polynomial functions like x squared and x to the fourth and x to the sixth. So that is concavity. All right. Now we already talked about this slide. If a function is going up, we call that increasing. And when a function is going down, that's called decreasing. And we're always moving from left to right when we talk about increasing and decreasing. So that's the difference between increasing and decreasing. One is going up, the other one is going down. Okay? All right, let's move on to the next slide. Okay, so for each function or graph that I show you, what we're going to be doing is we're going to be identifying intervals of increase, decrease, and constant, right? We're going to have to list out intervals of increase, decrease, and constant. So let me go ahead and label increase right here. We're going to have increase. And then below that, we're going to do intervals of decrease, decrease, and then intervals of constant. That means the function is basically flat. Okay, now when we do intervals, we're talking about intervals of the x-axis. We're talking about intervals of the x-axis. So whenever I say intervals, I'm always going to be talking about x-axis. So we're going to be following the x-axis when we do this. And what we're going to do is we're going to start at the left side and we're going to move to the right side. So we always start on the left on the x-axis and we move our way to the right. Okay, so let's look at this function we got right here. The first thing I'll say about this is the function is constant, right? It's constant until we get to this point right here. And this point would be -3, -3. So from negative infinity to -3, the function is constant. So what we can say is x is going to be between negative infinity and -3. And I'll put the -3 with a less than or equal to symbol. So you can write it as an interval if you want to. Basically, we're just looking at the graph, we're looking at the x-axis, and we're seeing which intervals on the x-axis is the function increasing, decreasing, or constant. So from negative infinity to -3, the function is flat. That means it's going to be constant. So you can write it like this, or you can write it like negative infinity to -3, and then close it up with a square bracket because we're going to include -3. Okay, so that is where the function is constant. And then the function starts going down. It starts going down, 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 until you get to 2, until you get to +2. And that's when the function is going down. So the interval of decrease would be from -3 to +2. So we're going to be saying that x, whenever x is between -3 and +2, the function is decreasing. It's going down. So we can write it as x is greater than or equal to -3 and also less than or equal to 2. Or we could say when x is between -3 square bracket and +2 square bracket. Okay. And that is the interval of decrease. Okay. And then once you get to the bottom right here, the function starts going up. The function starts going up. So we say that the function is increasing for x being between 2 and positive infinity. Positive infinity. So we could say 2 less than or equal to x less than positive infinity, right? We can write it that way, or we can write it as between 2 and positive infinity. So another way we can write this is x is greater than or equal to 2, because when x is greater than or equal to 2, the function is going up. So we call that increasing. So we can put that right there, and we can label the constant as x less than or equal to -3. We could also write it that way. So there are a couple ways you can write these intervals, but we're always thinking about intervals of the x-axis, never the y-axis. So we're always going to be looking at x when we do intervals of increase, decrease, and constant. Okay, and I'll leave that up there for a minute. Okay, so that is increase, decrease, and constant. Constant is when the function is flat. It's not going up, it's not going down, it's just staying flat. It's staying constant, right? And then the function is increasing when it's going up, and then the function is decreasing when it's going down. And that's all you're trying to figure out. You're trying to figure out on what intervals on the x-axis is the function going constant, or whether it's increasing or whether it's decreasing. Okay, now we have a new graph that we want to look at. We want to identify intervals of increase, decrease, and constant. So just like last time, I'm going to have my increasing intervals. We'll put that at the top. I'll have my intervals of decrease. I'll put those right here. And we'll have our intervals of constant. I'll put that right here. Okay, so we're going to track this function as it moves from left to right. So looking at this function, it starts off going up. It goes up, 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 up the hill until you get to the top of the hill, and then it stops increasing and it starts going down again. It starts decreasing. So right here, we can say from negative infinity to, what is this, -3 on the x-axis, the function is increasing. So we can say that the function is increasing when x is less than or equal to -3. So all the way up to -3 on the x-axis, the function is going up until you get to -3, and then the function starts going down again. It goes down, 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 right? Until you get to the bottom of the hill, which would be right here. Then the function is going to start increasing again. So what is the interval of decrease? It is from -3 to +1. +1 on the x-axis. So we can say from -3 to +1, the function is decreasing. And then from 1, you start going up again. You start going up the hill until you get to this point. Then the function starts going constant. So what is this point? This would be 1, 2, 3, 4. So this is at x equals 4. The function stops increasing and it starts going constant. So we can say that the function is increasing from 1 to 4. From 1 to 4, the function is increasing, right? It's going up. And then from 4 to positive infinity, the function is constant. So we can say when x is greater than or equal to 4, the function is flat. It is constant. So those are the intervals. Okay, so those are the intervals on the x-axis where the function is increasing, decreasing, and staying constant. We can write these in a different way. We can write the x is less than or equal to -3 as between negative infinity and -3. So we can write it this way. We can also write the increasing interval 1 to 4 as the square brackets 1 comma 4. So that would be the interval between 1 and 4. The function is also increasing. The function is decreasing from -3 to +1. So we can write this as from -3 to +1, the function is decreasing, and the function is going to be constant from 4 going all the way to the right. So that would be positive infinity. So that's just another way you can write these intervals. So we're trying to identify intervals on the x-axis where the function is increasing, decreasing, and where it's staying constant. That's what we're trying to do today. Okay, and I'll leave that up there for a few seconds. So I really think the roller coaster idea is a really good idea. You know, if you think about roller coasters, you know, as it goes up, it goes so slow, and you know, it goes up, 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 until it gets to the top of the hill, which is called the maximum, right? A relative maximum. Relative maximum. And then it flies down the hill, which means the function is decreasing until it reaches the bottom of the hill. We call that the relative minimum. The relative minimum. And then the function goes back up the hill until it reaches the top again. It reaches another maximum. And then it goes constant. So that's a really good way to think about these problems. Okay. All right, now for this function, we're going to label increasing, decreasing, and constant. So we're going to have increasing intervals. I'll put that right here. We're going to have decreasing intervals. And we're going to have intervals where the function is constant. And I usually put that last. Okay, so what we want to do is we want to follow this function as it goes from left to right. So starting on the very left side, the function is going down. It's going down, 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 down until you get to the bottom of the hill. Then it starts increasing. It starts going up, 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 up until you get to the top of the hill. And then it starts going down again. It starts decreasing. And then it decreases all the way to negative infinity on the right side. So where is the function decreasing? It's decreasing from negative infinity to -1. -1. So we can say x is less than or equal to -1. We can also write this as from negative infinity to -1. So on that interval, it's going to be decreasing. And then from -1, it starts increasing again. And where does it stop increasing? At the top of the hill, right? At x equals 1. So from -1 to +1, the function is increasing. So we say that whenever x is between -1 and +1, the function is increasing. So we can also write this as from -1 to +1 using square brackets because we want to include the endpoints. Okay? And then after that, the function starts decreasing again. It starts decreasing. So we can say x is greater than or equal to +1. And the way I would write that is from 1 to positive infinity. The function is decreasing. And that's it. We're done. We labeled all the intervals moving from the left side all the way to the right side. We know where the function is going down. We also know where the function is going up. Also, notice that the function is never constant. It's never flat. So we don't have any intervals of constant, right? We only have intervals of increasing and decreasing for this function. Okay, let's move on to the next slide. Okay, for this function, just like the others, we want to identify intervals of increase, decrease, and constant. So I'm going to put increase up here, and then decrease, and then constant. Okay, so we're going to follow this function as it moves from left to right. So starting on the left side, we start at -5 right here. This would be -5. The function starts right here and it starts going up until you reach -3. So this interval, we are increasing. We are increasing from -5 to -3. So we can write that as x is between -5 and -3. The function is increasing. Okay. Then the function starts going down. It starts going down from -3 all the way to 0. The function is decreasing. So from -3 all the way to 0. So we can write that as x is between -3 and 0. And then the function starts increasing again. It increases from 0 all the way to 5. That would be the top of that hill. So from here all the way to here, the function is increasing. So we say when x is between 0 and 5, the function is increasing. So 0 less than or equal to x less than or equal to 5. And then the function starts decreasing again. It goes down all the way from x is 5 to x is 7. So we'll say x is between 5 and 7. And that's it. We're done. We're moving from the left all the way to the right. And we're following the function as it goes up and as it goes down. And since the function is never flat, we don't have any intervals of the function being constant, just increasing and decreasing. All right, and I'll leave that up there for a little while. Now, another way we can write these intervals is using set notation, right? We can write this interval as between -3, whoops. We could say as between -5 and -3. And we can say from 0 to 5. So we can also write it this way. And then this interval would be from -3 to 0. And then this interval would be from 5 to 7. So just another way we can write these intervals. So you're trying to tell where the function is increasing, where the function is decreasing, and where it's staying flat, where it's constant. Okay, so now let's talk about the parent functions. So the parent functions are also going to display this behavior, whether the function is going up or whether the function is going down or where it's just staying flat. We can identify all those intervals. So let's start off with the first parent function, y equals x. This is just going to be a straight line through the origin. And the slope of this line is actually going to be +1. So the function is always increasing. So the way we would say that is the function is increasing on all real numbers. So we can say all real numbers. We can write it as a capital R, or we can write it out with words. We can say all real numbers. So this means the function is always going up. It's never going down. It's never staying flat. It's always increasing. So that's the first parent function. The next parent function is y equals x squared. This is that U shape that we've been talking about. And it decreases all the way to 0, this point right here. And then it starts increasing again. So we say that the function is decreasing when x is less than or equal to 0. But the function is increasing when x is greater than or equal to 0. So another way we can write this is from negative infinity to 0. And another way we can write this is from 0 to positive infinity. Okay, so that's y equals x squared. And then the last one on the screen is going to be f of x equals x cubed. So this is going to be that cubic function. And notice as we go from left to right, the function is always going up. It's always going up, right? So we say that it's increasing on all real numbers. It's increasing on all real numbers. There we go. So that's the difference between y equals x squared, and y equals x cubed. They all have different shapes, which means they're going to have different intervals of increasing and decreasing. Okay? So now let's look at some other parent functions that you might run into. Okay, so over here you have the square root function. In the middle, we have the cube root function. And then over here, we have y equals the absolute value of x. And we're going to find all those intervals, whether the function is going up, whether the function is going down, or whether it's just staying flat, whether it's constant. So for the first function, this is the square root function. We start right here at the point 0, 0, and we go up from there. And we keep on going up, right? So this function is increasing on its entire domain. Now, we can't write all real numbers, right? Because the function is not defined for negative numbers. So we pretty much have to start at 0 and go to the right. So I'm going to say x is increasing, or f of x is increasing on the interval x is greater than or equal to 0, or from 0 to positive infinity. And once again, when we look at these intervals, we're looking at the x-axis. We're not looking at the y-axis. So we're only looking at intervals on the x-axis when we do these. Now the cube root function, it's always going up. So we can say that this function is increasing on its domain, which would be all real numbers. So we can say this one is increasing on R, the symbol for all real numbers. Okay, so that is the cube root function. That is its shape. It's always increasing as you move from left to right. Now the absolute value symbol is a little bit different. When we look at the absolute value function, as we move in from the left, it is going down. It goes down, 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 down until you get to 0. And then it stops and it starts going up again. So it's increasing now. So the function is decreasing. It's decreasing from negative infinity to 0. So we can say it's decreasing when x is less than or equal to 0. But it's going to be increasing when x is greater than or equal to 0. When x is on the positive side, it's increasing. But when x is on the negative side, it is decreasing. So we can say from negative infinity to 0, the function is decreasing, and from 0 to positive infinity, the function is increasing. So that is the absolute value function. It's always going to have that V shape to it. And it's decreasing until you get to 0, And then once you leave from 0 and go into the positive numbers, it starts increasing again. So in a way, the absolute value function is a lot like the y equals x squared function. It's very similar, right? Because when you have that U shape, the function is decreasing until you get to the vertex, which is the bottom of the hill, and then it starts increasing as you go to the right of 0. So those two functions are actually very similar. Okay? All right, let's move on to the next slide. Coach, how you doing? You have anything to say to my Algebra 2 students?
Keep working hard and keep trying.
Yep. Even when things seem like, they don't even make sense, you want to reach out for help and get that help that you need, right?
Correct.
Okay. Anything new in your world?
Welcome back.
Okay. All right. So for this function, we're looking at y equals 2 to the x power. So this is an exponential function. And this function is actually the graph of exponential growth. So we're going to be identifying intervals of increase when the function is going up. We're going to be identifying intervals of decrease when the function is going down, and intervals where the function is constant, right? If it's flat, we would say the function is constant. So looking at this function, as we move in from left and we go to the right, the function is always increasing, right? So we can say that this function is increasing everywhere or on all real numbers. So this function is increasing on all real numbers. It's never decreasing, it's never constant, so we can say that it's always increasing. Now for the next function, this is a logarithm. So that means it's going to have a vertical asymptote on the y-axis. So I'll just kind of continue that as a dotted line so you kind of get what I'm saying. This function is never going to pass the y-axis. So its domain is going to be x is greater than 0. X is greater than 0. So everything to the right of 0, there's going to be a point. But we're not identifying domain and range today, right? We're identifying increasing and decreasing. So what is the function doing as it's going from left to right? It's going up. It's increasing, right? So we can say the function is increasing on x is greater than 0. Or in other words, we can say the function is increasing from 0 to positive infinity. And the function, if it continues going to the right, it's going to keep on going up. So we say the function is always increasing on its domain. Okay? So that is the logarithmic function. And then the last function we're going to look at on the screen is the reciprocal function, y equals 1 over x. 1 over x. So we know that this function, it has a broken up domain because of the vertical asymptote. It has a vertical asymptote on the y-axis, right? So I'll continue those dotted lines. There's also a horizontal asymptote, but that doesn't necessarily break up the domain. That only breaks up the range, right? So let's take a look at this function and we'll see whether it's going up, whether it's going down, or whether it's staying flat. So as we start off from the left side, it's going down, right? It's going down, 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 until we hit that vertical asymptote, and then it pops over on the other side and it keeps on going down. It's going down the whole time. So where is the function decreasing? It's decreasing on all real numbers except for 0. All real numbers except 0. Except x equals 0. Because that's where the vertical asymptote is, right? It's never increasing. It's never going up as you move from left to right. It's always decreasing. So that's going to be the reciprocal function, y equals 1 over x. It has that vertical asymptote at x equals 0, and that's the only place where the function is not defined on the y-axis. Okay, so now I've got three formulas that I want to look at, and for each function, I want to identify three things. I want to identify the parent function, I want to identify any transformations that might be going on, and I want to identify those intervals of increasing, decreasing, and constant. So for this first function, we've got y equals -3 on the outside, x plus 1 on the inside. Everything is squared, so we know the function is probably going to have a u shape to it, and we have a +2 on the outside. So the parent function is going to be y equals x squared. It is that quadratic function that you're very familiar with at this point. It is the quadratic function. So it is going to have a u shape when we graph it. But what is the transformation? What's actually going on here that's changing the function? Well, we've basically got four things. This, 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 and this. So the +2 on the outside means we're going up 2. We're going up by 2. And then the +1 on the inside means that we're going left 1. We're going left by 1. And then we've got this 3 on the outside. That's going to be a stretch. You can call that a vertical stretch by 3. A vertical stretch by 3. By a factor of 3. And the negative on the outside is going to give you that reflection over the x-axis. So we can say that the function is being reflected over the x-axis. So let's actually graph this and see what it looks like. So I'm going to be moving over to Desmos, and I'm going to be graphing that function. We're going to be seeing what it actually looks like. So y equals -3, x plus 1 on the inside. We're going to square it, and then we're going to add 2 on the outside. So taking a look at this function, where is it increasing? Where is it decreasing? And where is it constant? That's what we want to figure out now. Where the function is increasing, where it's decreasing, and where it's staying constant. So as we move in from the left, the function is clearly going up, and it goes up until it reaches the top of the hill. What x value is that top of the hill? It's going to be -1. So we're going to say x is less than or equal to -1. Less than or equal to -1. The function is increasing. So that's going to be our increasing interval. And where is the function decreasing? To the right of -1. So x is greater than or equal to -1. That's where the function is going down. And if you take a look at the graph, as you move past the top of the hill, it is moving downwards as you move from left to right. So that is why the function is going up and down. Okay. So that's number 1. Let's look at number 2. What is the parent function for this one? We have a number raised to an x power, right? So this is the exponential function, y equals a to the x power. So this is the exponential function. Exponential function. So what transformations are going on here? Well, there's really only one transformation to really speak of. It's this negative on the outside. And you know, if we multiply by a negative number, that means we're reflecting over the x-axis. So we're reflecting over the x-axis. That is the only transformation that's going on. So let's take a look at this graph. Let's graph it, and let's see if we can identify the intervals of increasing and decreasing. So moving over to Desmos, I'm just going to type in y equals -4 to the x power. There we go. And we get this green function. So as we move from left to right, and let me see if I can grab the point. There we go. As we move from left to right, we notice that the function is displaying asymptotic action as we move from left to right. And that's because there's a horizontal asymptote right here on the x-axis. But as we move from left to right, the function is going down. The function is going down, and it picks up speed as you move from left to right. So we say that the function is decreasing on its entire domain, which would be all real numbers. So for all real numbers, the function is decreasing. So moving back to my slide, I'm going to say the function is decreasing on all real numbers. All real numbers. There's no vertical asymptotes to speak of, so the domain isn't broken up at all. It's just going to be all real numbers. Okay? And the last one we're going to do today is this absolute value function. So yes, this is the absolute value function. And you can tell because it has that absolute value symbol with it. We say that y equals absolute value of x, or we can write it out in words as the absolute value function. But what is the transformation that's going on? What is the transformation? Well, we have two things that are going on, right? We have a -3 on the inside, which means we're moving to the right by 3. We also have a -5 on the outside, which means we're moving down 5. We're moving down 5. So what I want to do is I want to graph this function, and I want to identify intervals where the function is increasing and where it's decreasing. So let's go on over to Desmos and let's graph this. So let me get rid of this, and we're going to graph y equals the absolute value of x minus 3, and then we'll have a -5 on the outside. There we go. So now we've got this purple function on our screen, and we want to identify intervals where the function is going down, where it's moving up, and where it might be constant. So as we move from left to right, we notice that the function is going down. It's going down, 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 down until we reach x equals 3. And then the function starts going up again. It starts going up, 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 and it's going to keep going up on its domain as we move to the right. So for this function, we say that the function is decreasing until we get to +3, and we say that it's increasing from 3 onwards. So how can we write this? Let's go back to our screen and see if we can write this. We can say x is decreasing. X is decreasing when x is less than or equal to +3. But if x is greater than or equal to +3, we say that the function is increasing. So those are our intervals of increasing and decreasing. And I hope that makes sense. Okay, I'll leave that up there for a little bit so you guys can copy that down. And then we'll move on to the last slide, and then we'll talk about what's going to be due on Sunday. Okay. So we're identifying parent function, transformations, intervals of increasing, decreasing, and constant. That's what we're focused on today. And that's what your classwork is going to be on. Increasing, decreasing, and constant. Okay. All right. And before I leave today, I did just want to talk a little bit about Extrema. And whenever we talk about extremes, we usually refer to the bottom of the hill and the top of the hill. So for this function, I'm only going to be doing the relative maximum and the relative minimum. So the maximum is the top of the hill. The maximum right here is going to be this point, which is 0,6. And then the bottom of the hill, which is over here, that's going to be our minimum. So this point is -6, -3. So we say that the function has a relative maximum at 0,6, and it has a relative minimum at -6, -3. And then we can also do intervals of increasing and decreasing on this function. But we're only going to be concerned about relative extrema, whether it has a relative maximum or whether it has a relative minimum. Now, we have relative extrema. We can also talk about absolute extrema. So you can have an absolute maximum and you can have an absolute minimum. So looking at this graph, where do you think that the maximum height of the roller coaster is going to be? The maximum height of the roller coaster. Well, it would be the highest point on the graph, right? That would be the absolute maximum, which would be right here. On the x-axis, we have 1,500, 1,500, and then on the y-axis, we have 80. So that is the absolute maximum, the highest point on the graph. We can also call it a relative maximum, but since this is the highest point on the entire graph, we say that it's absolute maximum. And then where is the absolute minimum? The absolute minimum would be at the very bottom of the graph, which would be right here at 3,900. And then the y coordinate, let's just say 8. So the absolute minimum would be at 3,900, 8. So that's absolute maximum, absolute minimum, and you can also have relative maximum and relative minimum. So that's what I mean by extrema. You can have a maximum of a function, and you can also have a minimum of a function. So what's going to be due on Sunday? You're going to have your 2 assignments. The first one is the increasing, decreasing. You can do that today. And then your second assignment is going to be end behavior, which is what we're going to be talking about on Wednesday. Okay, and that's all I wanted to talk about today. Class dismissed. If you have any questions about today's lecture or on any of your homework, you could stay after. I'll be staying after for about 10 minutes helping out students. So if you do need that help, stay on the Zoom meeting. I will get to you. Go ahead and put your questions in the chat box. And for the rest of you, I will see you on Wednesday. Have a great week.